myself.
Feels like spring.
Oh yeah. Closer we get to spring, the colder it gets. Are you originally from Alabama?
Not originally.
Okay.
I lived here
What's that?
I lived here for a long time.
For a long time, so you're used to this change, huh?
Yeah.
Okay. I heard the bookstore manager on the phone with some book company somewhere else. He said something about Alabama, where we can have all 4 seasons in 2 weeks. And it does feel that way. All right. Let's see. We are recording, but although got that started before you came in. Still have the information on Executive Women's International, their scholarship program, adult students in scholastic transitions. And also, these are the old ones, but the Financial Services Office has a listing every month, as far as I know, of scholarship deadlines for that month. And there's amazing numbers of them. And okay, I think we're ready to go. I thought we were, but the slideshow is still not from current slide. Okay, here we are. All right, any questions from anything so far? Did you get you didn't get the test for chapter 2, did you? Okay, let me find that quickly. Here we go. And we started chapter 3, didn't get very far in it, we just got started in chapter 3 last time. Okay, and no questions, then we'll go. We're on page 104, this is chapter 2, determinants, 3.1, determinant of a matrix, and we're doing example 1b. We did 1a last time. Here is the matrix B. Get my pen. Okay. Matrix B, and they're starting us really easy, even though we've already done these. 2, 1, 4, 2. And it asks for the determinant of B. And what would that be? B for B. Which is 0. Do you remember what that means for us? Okay. Yeah, there's several things that it does and can mean, and what we used before. This matrix is not invertible. That was why we did determinants in the last chapter, was looking at invertibility of matrix. Then the other word, if a matrix isn't invertible, it has another name, and what is it? That? Second? If it's not invertible, it is called singular. This is a singular matrix. Now, 2 by 2s, really easy to tell that, because one row is going to be a multiple of another row. And this obviously is that case. 3 by 3s and on up, nah, you can't tell that. But neither are determinants as easy to take on those either. So, but this is just giving you practice for determinants. How about C here? C is the matrix 0, 3 halves, 2, 4. Okay. What is the determinant of C? Negative, isn't that 3? It's 3 halves, not 1 half. Yeah, negative 3. Perfect. Okay. What's that? Negative. right? Okay, 0 times 4 is 0, of course, minus half of 3 halves, twice 3 halves is 3, but the down diagonal is negative. 0 minus 3. Okay. All right. Now, I guess it's necessary mostly to know the terminology, but I even question that. But they like to focus on these terms called minors and cofactors. Okay? Have you done matrices before, or determinants of matrices before? Determinants? Yeah, I know that we did before, but have you done it before this class?
Yeah.
Huh? No, before this class.
Oh, and calculus,
Okay, yeah, okay. Before you came here, okay. No, you hadn't done it, okay. The reason I ask this, we usually just use them like we have done in Cal 3 and in Chapter 2 in places without messing around with these concepts of minors and cofactors. And frankly, it's just sort of, it does explain what you're doing, but then once you're used to doing it, I space it out and don't call them that anymore, I just use them, okay? It's kind of like the quadratic formula is based on completing the square, right? That's how you get it, you know. But once you have the quadratic formula, I don't then every time I do it think, oh yeah, this is from completing the square, you know, because I just use the quadratic formula. Basically do the same thing with matrices without, at first we learn minors and cofactors, but then after a while, who calls them that? I mean, some people may. Maybe this is the way they like to learn it. To me, these are just names to keep up with. All right. Now, first, what has to be true about A if you can take a determinant? Has to be square. Got to be a square matrix. You don't care about it if it's not, okay? You don't mess with determinants if it's not a square matrix, okay? So, if A is a square matrix, okay, then the minor Mij, that's called the minor, of the entry Aij, okay, is the determinant, okay, of the matrix obtained by deleting the ith row and the jth column, okay, of A, okay? So, and we do this all the time, okay? I do it. This is how you do it. But do I stop and think, oh, this is a minor, okay? No, I don't. Maybe I should, but I don't, okay? Now, second definition. This is the minor. Okay, that's what this is, okay? Second is the cofactor. Cij, okay, of the entry Ij, Aij, okay, is Cij is equal to, and where this is here. So the two middle part of the alphabet are here. Where's the top and the bottom? Okay. So what is this cofactor? Okay, it's this. -1 raised to the ith plus jth power, I plus jth power, times the minor ij. Okay? And again, you do this every time, okay, that you're taking a determinant. But I never go back and say, oh, yes, this is a cofactor. You know, you just do it, okay, just like you do it for the minor, okay? So you basically get the minor, and then the cofactor is just, is this. It's a sign. It's a sign, okay. What it is plus or minus. It just determines whether you use the plus or the minus of that minor. Okay? And the minor is a determinant, a smaller determinant. So let's say we had a 3 by 3, okay? I'm going to go on and clear this just because it might take me a bit more room to write the rest of it. Here's a 3 by 3 matrix A, A11, A12, A13, A21, A22, A23, A31, A32, A33. Pick one of those elements. Any one. I don't care. Pick one. A22? Okay. A22. Okay. Now, what we're going to do first is find the minor M22. And what you do, you wipe out the second column and second row. Just wipe them out. The matrix that's left, you take the determinant of that. And that determinant would then be A, you tell me. 1, 1. Not 1, 3. 3, 3. There's a sign. Give me a sign. Minus. Okay? And what do you say next? A13, A31. You got it. That is the minor M22 for that matrix. Wipe out the ith row, the second row, and the jth column, second column, and then take the determinant of what's left. Okay? Now, what would be the cofactor? C22. You chose 22. What is C22? All it is a sign on that. What sign do you use? Okay, which is? Positive 1. So it's just a sign. So the cofactor is the same as the minor because 2 plus 2 is 4. Now, do I add those and raise negative 1 to that power every time? No. Here's the easier way. Check it out. Start upper left, it's always positive. 1, 1 is 1 plus 1 is 2, right? Get this. Watch. Okay? Plus, minus, plus, minus, plus, minus, plus, minus, plus. Or plus, minus, plus, minus, plus, minus, plus, minus, plus. Or plus, minus, plus, minus, plus, minus, plus, minus, plus. Or any way you do it, as long as you don't go diagonally, if you go horizontally and vertically and don't repeat, don't back up on yourself, you are going to always get it right that way. So do I worry about raising minus 1 to the I plus j? No, I just look at it and say, that's a positive place. So in other words, get this, your diagonals are always positive, right? Because 1 plus 1 is even, 2 plus 2 is even, 3 plus 3 is even. Those are always even. Your, and then you can just do plus, minus, plus, minus. So that's what the cofactor is. So I just, if I'm using this entry here, wipe out the row and column, and do the matrix. That's the minor, and then determine the sign of that position, basically, is what you're doing. And it's either plus or minus. This one happens to be plus. Okay. Not a difficult thing to do. Pick another one. Another entry. 2, 3. Okay, this one. What's the first thing we're going to do? Right, about the second row in the third column. That's the one you said, 2, 3, right? Okay, and then what do you do? What is the minor for 2, 3? A11, A32, minus A12, A31. Okay, what's the cofactor for 2, 3? Say again? The negative of that. You got it. I didn't need parentheses there. I started to write that whole thing down. I said, no, I'm way too lazy to do that. I'll just put it on 2, 3. So that's why I started putting on parentheses. Okay, that's it. Big blurb about minors and cofactors. As it turns out, you just do it. Okay. And then in the book, you'll see that sign pattern. They show up there, and you'll see the main diagonal is always positive, and you do plus minus from there. You know, it's a piece of cake. Okay. Now, next is going to take a little while, okay? So let's do it. Find all the minors and cofactors of A. They love A, don't they? It's like X for a variable. 0, 2, 1, 3, minus 1, 2, 4, 0, 1. Okay? Let's do the first one. Which you want to be first? 1, 1. M, 1, 1. You tell me what it is. Negative. Is that right? -1. What's the cofactor? Yeah, cofactor for 1, 1. Okay, it's the positive value of the minor. And the minor is -1, so plus or minus 1 is still -1. Okay, so you don't change the sign. Okay. Which one you want to do next? Which one? 1, 2. M, 1, 2. Sorry, I don't hear well. I keep having to ask. Okay? You tell me what the minor for 1, 2 is. 3 minus 8, is that what you said? And what's that? Did you say an answer? I don't hear. Which is? -5. Okay. Minor is -5. What's the cofactor for 1, 2? 5. You got it. Okay, which one you want to do next? 1, 3. Minor for 1, 3 is what? Is it -4? +4, okay. And what's the cofactor for 1, 3? Positive of that, which is 4, okay? Which one you want to do next? M, 2, 1. What would that be? What'd you say? I couldn't hear. 2, yeah, okay. And what's the cofactor for 2, 1? Say again? -2, right, got it. Next, I take it you're going to do M2, 2, okay. And what's the minor? -4, what's the cofactor? -4. Got it. M23. -8. Cofactor of 2, 3. Second? Really? Okay. Yeah, I think it is. I got lost there in the sauce for a minute. 2, 3, yeah. Okay, next. M3, 1. Five. Cofactor 3, 1. Really? Huh? +5. And actually, I sort of didn't quite like before, but when you're writing them this way, just look at that and see if those add to be equal. If it is, the sign doesn't change. If it adds to be odd, the sign changes. Okay? Now, so I sort of do what they say, but I don't really think about it that much. Okay, M3, 2. Say that again. -3. Okay. And C3, 2. Change the sign, right. And the last one, I guess I have to go down here, M3, 3. A little louder. Okay, so -6. Okay, and cofactor 3, 3. -6 again, because keeps the sign. Okay. They wrote them differently, but we'll see. -1, -5, 4. 2, -4, -8. 5, -3, -6. They got all those right. Cofactors, they got -1, 5, 4. -2, -4, 8. 5, 3, 6. -6, right. Got it. All right, good for them. Proud of them. Okay. Now, the definition below is called an inductive definition because it uses the determinant of a square matrix of order n-1 to define the determinant of a square matrix of order n. Okay? So I think we'll probably need to clear this. And here's the definition of the determinant of a square matrix. So we start out A square. Okay. Of order n greater than or equal to 2. We don't worry about 1 by 1s too much, do we? That's just a number. Okay, so any order n greater than 2, that's 2 by 2 and up, yeah. All you've excluded is your 1 by 1 matrix. And the 0 matrix, of course, we haven't worried with that one either. Okay. Then the determinant of, well, I mean, 0 matrix could be order n greater than 2, but never mind. Okay, then the determinant of A, okay, is the sum of the entries of the first row of A, sum of entries of first row of A, okay, multiplied by their respective cofactors. Their cofactors. That is the determinant of A. I didn't write it but one way, they wrote it two ways. is the sum from J equal 1 to N, because this is an N-size matrix, okay, of Aij, no, A1J, sorry, we're using the first row. Okay, using the first row only. 1J, C1J, C1J. Okay. Now, what that turns out being is A11, C11, plus A12, C12, plus A13, C13, plus dot, 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 plus A1N, C1N. Okay. Now, does that work for a 2 by 2 matrix? As we said, N could be equal to 2. Well, you take A11 and multiply it by its cofactors. So wipe out here and here, and you just multiply it by A22. Yeah. Okay. Plus A12, that's this entry here, times the cofactor of 1, 2. The cofactor, that's a negative position, so it's negative this. But yeah, it works for a 2 by 2. Okay? And we just sort of, we didn't show that it did, but showed how to do the things for a 3 by 3. Okay. When you when you use this definition to evaluate a determinant, you're expanding the cofactors in the first row. I'm sorry. They're waiting till later to tell you this, but I'll tell you now. It doesn't matter which row you choose. You could choose any row. It doesn't have to be the first row. What's more, you could choose any column you wanted to. It doesn't matter. You could choose any column, and it works. But you just do it once. Pick a row, or a column, and then go down that row or across the row or down the column, doing the entry from that row or column times the cofactor of that entry. Okay, and that's how you get the determinant of the matrix. Now, 3 by 3, we've already determined what the cofactors are. We just did that in the previous one. What happens when you get to a 4 by 4 though? Let's just say we've got the first entry. The cofactor of that one is now a 3 by 3 matrix, right? Which now you have to take that and do its for, so you do this regressively kind of. You have to do this over and over and over until you get down to a 2 by 2, and then you got it knocked. Okay? So, let's do example 3. Okay. Here is A. 0 to 1. Have we seen this before? 3, negative 1, 2, and 4, 0, 1. Yep, that was example 2, wasn't it? If I still had them on the board, which my board isn't big enough to have them, we would have everything we needed. Okay? So if you can go back in your notes, hopefully you were taking them, and we'll use, like they say, the first row. Okay? But let me just give you another little hint here. If I were doing this, first row is perfectly fine. In fact, that would be my choice. You could use first column. I wouldn't go with that because these numbers are bigger. Okay? I just go with small numbers. You could use the second column. because those are fairly small numbers. No better than the first row. You have a minus, you might mess that up, or whatever. Or I would use the third row, because the reason, I'd pick a row or column with a 0 in it. In fact, I'd pick the row or column with the most number of zeros in it, because that's going to make the calculations easier, as you will see when we do row 1. So let's do row 1. What would that be? A11 is 0. It doesn't matter what the cofactor is. We figured it. What did we find it to be? Second? For 1, 1, yeah, -1. 0 times -1. Okay? Next. Okay. Now here's where I differ from the way they do it. Okay? And don't let this confuse you. Okay? Don't let it confuse you. I hope I'm not going to confuse you here. But rather than putting the minus sign with the cofactor, I just put the minus sign with the 2, because that's a negative position. So you see, that's why I really don't use the other things, and then do the determinant of what's left, which basically is the minor from before. And if you go back to the minor from before, the minor for 1, 2 was -5. Now, they do a +2 times the cofactor, okay? If you want to do it that way, do it that way, okay? But I like to take the sign, because when I look at that, the first one's a positive, the next one's a negative, the next one's a positive. So I just change the signs for the entry and then use the minor, not the cofactor. But it doesn't matter which way you do, okay? The next one is pretty obvious. It's +1 times, and what was the cofactor of 1, 3, 4, which is also the minor of that, okay? And what does this add to? First one is 0 plus 10 plus 4, 14. There's the determinant of A. Should put determinant there. So A isn't that, determinant of A is that. Okay. Okay. Guess I could have put, this leads to that. Okay. Let's see if they got it right. Yep, 14. Good for them. Now, although the determinant is defined as an expansion by the cofactors in the first row, it can be shown that the determinant can be evaluated by expanding any row or any column, okay? And you can go back to that A again, and you pick me either another row or another column. I gave you several choices, but you can choose any one you want to, other than the first row. Second column, I like that one. So determinant of A from that would be, okay, now this is how I do it. If this confuses you, don't do it this way, do it the way the book says. But when I look, second column, that first entry is a 2, I know that's a negative entry, okay? So I'm going to put -2. And then I just do times the minor 2, 1. And we already did the minor 2, 1 was -5, wasn't it? Yeah. 1, 2. I said 2, 1. 1, 2. Okay? Now, next, if you're going down the second column, -1. And that is a negative, stays a -1 because that's a positive position. Okay? And then the either minor or cofactor, they're going to be the same. For 2, 2 is -4. Okay? And then I can do the last one. 0. Okay, you beat me to it. Okay. I told you I was going to do it. Okay. What does this add to? 10 plus 4 equals 14. Doesn't matter which one you do. Pick a row, pick a column, do it. Okay? Now, what I do differently is rather than doing a separate cofactor, I just keep up with the sign position. Okay? And that takes care of the cofactor for me, and then I just do the minor, the determinant of the minor. Okay? But if you want to do it the way the book does, it works perfectly fine. All right. Now, here is a possible, reason to use cofactors. Okay? Theorem 3.1, expansion by cofactors. Again, we're going to start with A being a square matrix, okay, of order n. Okay? Of order n. Then, this implies the determinant of A is given by this summation. Summation of j equal 1 to n. This looks familiar, doesn't it? A, this time it is ij. Cij, okay, which is a I1 CI1 plus a I2 CI2 plus, I'm just going to say dot dot dot, plus a IN CIN. Okay. Or the determinant of A can be choose a column. Okay? Is equal to I equal 1 to n. Okay? Aij, Cij, which is A1J, C1J plus A2J, C2J plus dot 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 all the way up to A NJ CNJ. Okay? Basically, it just says choose a row, choose a column, doesn't matter which. For any I you choose, you use that one and that one only up there. Or any J you choose down here, use that one and that one only, and you got it. Okay? That's formally by the definition. In practice, I find it easier not necessarily to use that. You're pretty close to it. So, when expanding by cofactors, and the way I do it is expanding by minors, but using the sign convention to change for me, you do not need to find cofactors of 0 entries. That's what I said. Yeah, we had already found them, but no need. That's going to be 0. The row or column containing the most zeros is usually the best choice for expansion by cofactors, by far. Okay? So let's do a 4 by 4. Okay, I can't count. Oh, that could be hairy, couldn't it? But maybe not. Here is A. This 4 by 4 matrix, which is 1, negative 2, 3, 0, negative 1, 1, 0, 2, 0, 2, 0, 3, 3, 4, 0, negative 2. I hope I copied it right. Okay, if I say find the determinant, that's what they say. What is the determinant of A? What would it be? And by the way, let me think which class it was. It was one of my calculus classes or the differential equation class 1, just Monday, I think it was, or Wednesday of last week. I think it was Monday, when we went to do a determinant they don't use the bars like this one does. They use those bars to mean absolute value. So they write out DET of A, and then they wanted to do the absolute value of the determinant of A, so then they did the bars around that. So it was a little confusing, but this book uses the bars. I love using the bars for this, but in some texts they don't use the bars for determinant. You have to write out DET. So since I had said that before, I wanted to tell you, yeah. All right, you choose now which row or column you'd like to use. Third column by far, okay? So the determinant of A will be, you tell me what to write. 3 times the determinant of the matrix that's left. So wipe out this, and the reason I put 3 there, it's in a positive position, plus, minus, plus, okay? All right. This determinant, negative 1, 1, 2, 0, 2, 3, 3, 4, negative 2. Boo hiss, it took out all but 1 0, okay? But that's why we used it, okay? Now, how we define the determinant of that matrix? Column 1 looks like the best choice to me too. Row 2 would be okay too. So this will be, remember your 3, don't throw it away. 3 times, I don't know, that's not a matrix bracket there. It's just something to, maybe parentheses would be better here. Okay. 3 times. Now you're going to use what you say first column, you said? Is that what you said? Okay. So what goes first? What goes first? Negative 1 times, can we do that one mentally? Does it help you if I wipe them out, or you're doing whatever you want to, I guess? What's the next? Negative 4 minus 12 would be negative 16. Okay, I can't hear. Okay. Next. 0. Not going to mess with that one. Next. Plus 3. That's a positive position. I'll do a plus 3, and then I'll do the, basically the minor, but I don't think about it being the minor. What would that be? Which is negative 1. All right. Done. So this is 3 times 16 minus 3. That would be 3 times 13, which is 39. I sure hope 39 works. Yes, it does. Good for them. Okay. See how that happens. Okay. Not too bad. Okay. Now, I never messed around with the cofactor at all. I did all the things that cofactors do, except I pull out the signs when I'm picking the elements, okay? Like that first 3 we chose, it was in a positive position. I put the sign with that, then only worried with the with the minor, which is the matrix that's left over. I don't think of it as a minor, but that's what it is. But then when you do that matrix that's left over, pick another row or column. Y'all chose the first column. I like that choice. So you do, and for that one, you start your entries again. You don't go back to what it was here. You use the entry for that. And that's a positive entry, minus 1, and then do the, it's a positive entry, but the number is negative, okay? And then do your matrix of the 2 by 2 that's left, and then it's a plus 3 because it's a plus 3 position. The 0 is a negative position, but it's still 0. Positive position, then do the matrix there, which is a -1. And sure enough, that gives you the answer. Don't forget that first one that you have there. All right, any questions on that? Now, for those who are in, okay, see, I'm doing this in 2 different places. Did I show you the expanded? I did, didn't I? A 3x3, how you expand? Yeah. We still do that, okay? We're doing that in vectors in Calc 3, too. But, okay. An alternative way to evaluate the determinant of a 3x3 matrix is to expand the first 2 rows again, augment, you might say, or whatever you want to call it, and then do your down diagonals are positive, your up diagonals are negative, okay? So let's do it. Do I need to show that, or are you okay with it? Okay. Trying to think the people who aren't here, if they have had this. The only one I'm sort of doubtful about is Jonathan. I think he would have, but I don't know. So let me go on and do it. Okay. Didn't want to take the time to do it, but I will. All right, let's say we have a 3x3 matrix. A11, A12, A13. A21, A22, A23. A31, A32, A33. What's the shortcut way to do your 3x3s? You tell me. Okay, columns. Okay. A11, A21, A31, and A21, A22, A23. You just repeat, 3-2. Goodness gracious. I botched it all up, didn't I? I'm used to saying them the other way. That one I could have left. Okay. Okay. A1, 1, A21, A31, A12, A22, A32. Okay. That time I got it right. Okay. Rather than having to do cofactors and that kind of stuff, just do your diagonals. This is a product. A11, A22, A33. Okay. The next one plus A12, A23, A31. Really important you keep things in a nice structured array here. And next plus A13, A21, A32. Now do your up diagonals, but you only do the up diagonals for those that have 3 in it. Don't try to do this first one. That's only got 2 elements. Only the ones with 3. That would be a minus A31, A22, A13, and you can do it any order. It doesn't matter. I'm just doing up the diagonal. This one would be minus A32, A23, A11, minus the last up diagonal is A33, A21, A12. Okay. Now, I don't know if this will be helpful for you. I hope it will. But really, it's only good when you've got these subscripts on here. But when you do have the subscripts, notice, for the first entry, you have a 1, 2, 3. For the second entry, 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. First entry, 1, 2, 3. 1, you don't ever, you have to have one each of your first and your I's and one each of your J's in those products. Again, that only is helpful when you got it in this form. But if you're using this form to build your others, then it's a good check. Most of the time I don't do that. For instance, the next example, example 5, we don't do that. And I swear, I forgot my watch, so I don't have a watch, so y'all let me know. Y'all are usually pretty good about it. What time is it? 9 o'clock. Okay. Okay. So let's do example 5. Find the determinant of A. Not the same one this time. 0, 2, 1, 3, negative 1, 2, and 4, negative 4, 1. Okay, I'm not even going to close that in because I'm going to take this, did I write it right? And you tell me how to expand it. What do I add? Yeah, and call out the numbers for me. 0, 2, going by rows. 3, negative 1. 4, negative 4. Okay, what's next? Yeah, multiply down your main diagonals. The first one gives you 0, okay. Second one gives you 16. Third one gives you negative 12, okay. First up diagonal, but you remember you do a minus of it. So what does that give you? Say again? But you're doing a minus of it. 4. That'll give you a plus 4. You see why? You had one minus in there, plus you had the minus for going up, so that gives you plus 4. Okay? Next diagonal. I was going to volunteer to do it, but I'll let you do it. 0. Yeah, okay. And the next one? Second? Only it's up diagonal, so it's minus 6. Right? Okay. However you want to keep those signs right, do it. Okay? All right. Now, you can add these any order you want to. What I think I'll do is 16 minus 6 is 10, and minus 12 plus 4 is minus 8, and that's going to be 2. Okay? Yep, that's what they got to. You can do them any way you want to. Now, you mentioned Cal 3. I mentioned differential equations. In one or both of those courses, can't remember which one now, we're going to hit a Jacobian, which basically is, okay. You know how in physics or in Cal 3 when we're doing vectors and doing cross products of vectors and we use determinants there and expanded? Well, Jacobians, you do the same thing, okay, or a very similar thing. If x, y, and z are continuous functions of u, v, and w, in other words, x, y, and z are not your independent variables. The independent variables are u, v, and w. X, y, and z are either dependent or intermediate. Okay. And if those three functions, x, y, and z, have continuous first partial derivatives, then the Jacobians, which are called juv and juvw, if you're 3 dimensions, are this. I guess I'll erase this. Because we haven't gotten to partials in Cal 3 yet. Hopefully we'll get there pretty soon. That's an important part of Cal 3. And in differential equations, we try to stay with ordinary differential equations, but there are times we use a Jacobian, which is dealing with partials. Okay? But y'all aren't, neither of you are in that class. The other two are, so that's why I'm saying it on here. Okay? Here's the Jacobian of a two-dimensional system. When you have two independent variables, u and v only, then this is going to be the determinant of partial of x with respect to u, partial of x with respect to v, make sure, yeah, partial of y with respect to u, partial of y with respect to v. Okay. Now, at this point, neither one of you have done a partial derivative, have you? We did a little bit. And in my 4 classes, advanced classes, I know that Cal 1 didn't, but in a couple of the others we did. I just don't remember which one we did. But anyway, if you need it, we'll get to it. In 3 dimensions, that Jacobian, u, v, and w, will be the determinant of partial of x with respect to u, partial of y with respect to u, partial of z with respect to u. No, I did it wrong. Sorry, wait, ignore that. Okay. You keep the x, the top one, and with respect to v and then w, then partial of y with respect to u, partial of y with respect to v, partial of y with respect to w, and then partial of z with respect to u, partial of z with respect to v, and partial of z with respect to w. Okay, it's that determinant. Okay? Now, for some reason they call this a practical use of Jacobians, is finding the volume of a solid region. In section 3.4, which is coming up later, you'll study the formula which also uses determinants for finding the volume of a tetrahedron. And in chapter 3 review, you're asked to find the Jacobian for a set of functions. Can't wait. Okay. But let's move on from here and go back to our triangular matrices. Do you remember what these are? What 2 kinds of triangular matrices have we talked about? Upper and lower. Okay? So they're doing this again from section 2.4. Upper triangular matrices is when it has all 0 entries. The upper is below the main diagonal, and the lower triangular is keep the main diagonal, and all above it are zeros. Okay? A matrix that is both upper and lower triangular is called a diagonal matrix, which means all it has is the main diagonal. The only non-zero entries are on the main diagonal. Okay. So, to find the determinant of a triangular matrix, whether it's upper or lower, it doesn't matter. And really easy if it's, well, we'll see. A is this matrix. Okay? 2, 3, 1. 0, minus 1, 2. 0, 0, 3. Okay? If I ask you to find the determinant of that matrix, you could do it one of 2 ways. One of many ways. You could either expand it, as we just did, because it's a 3 by 3. But when you look at it, what do you notice? Lots of zeros. So you could just do, what's your technique? The first one we did. Yeah, using that. Pick a row or pick a column. Which one you want to pick? First column, why not? Okay? And what would you do with that? So the determinant of A would be 2. Got it? It's in a positive position. And then you have the determinant of what's left. And what's that? -3. Okay, done. And guess what the others are? 0, 0. So guess what? Your determinant is? -6. Okay. What if you had chosen the third row? I like that just about as well. Then you would have had a 0, a 0, and then you'd have had a +3 times -2, which is also -6. So either way. Now what's something else you notice about that? Have you noticed it yet? What's that? I can't hear you. Oh, you want to do an upper triangular there? Oh, this is an upper triangle. Yeah, I said for any triangular matrix, this is what you would do. See, this is so much easier than expanding this next to, yeah. So if you got a triangular matrix, don't worry with expanding it, just use it. Okay. But what is the other thing you might notice here? Look at this. That's the product of your diagonal. That's all, folks. Because these have zeros otherwise, they don't contribute anything. That first one, the 2, had this, but this one doesn't contribute because of that 0. So basically it was only the diagonal element. This one, you did this, but this one didn't contribute anything because of that diagonal, the 0 there. So it didn't matter, okay? So yes, you basically have just the product. So if you have either triangular matrix, upper or lower, your determinant is the product of your main diagonal. And that's it. That's all. Okay. All right. So that leads to 3.2, which I think I'll write here. How are we doing on time? 9 minutes left? 4 minutes left. Okay. Anyone give me 3? 3. No. Okay. All right. If A is a triangular matrix, okay, now that implies it's square, okay, positive square of order n, which also implies it's square, then its determinant is the product of the entries in the main diagonals. Okay? That is, the determinant of A is equal to A11, A22, A33, ... times ANN. That's all, folks. Okay. Here's one other little tidbit here. And it's pretty obvious for a 3x3, I think. But it'll be for any size matrix. If one of those diagonal elements is a 0, then the determinant is 0. What else does that tell you? The determinant of a matrix is 0. Non-invertible. It's a singular matrix. You're absolutely right. Way to go. All right. They do a little proof here. I'll let you look at it. Do we have time for example 6? 2 minutes? Let's try it. Okay? All right. Find the determinant of this matrix. A. It's going to take me almost 2 minutes to write it. 2, 0, 0, 0. 4, negative 2, 0, 0. Negative 5, 6, 1, 0. 1, 5, 3, 3. What do you notice about that matrix? It's a triangular matrix, specifically a lower triangular matrix. So what's its determinant? The product of the diagonal, and what would that be? Did you give me an answer? I can't hear. Negative 12. Got it. Let's do a lot of these, okay? No, I'm just kidding. Okay. That finished 3.1. Homework exercises, any of the odds 1 through 11. Do either 13 or 15 or both. Do 17. Do any of the odds 19 to 31. Do 33. Do either 35 or 37. Okay. They say you might need some assistance on the 37. Actually, to me, it looks almost easier than 35, but you can use calculator if it's fine. You do either 39 or 41 or both. Do 43, either 45 or 47 or both, either 49 or 51 or both. I would definitely do one of those. We didn't do one like them in class, but do them. You're going to see those later, okay? Do either any of the odds 53 to 57. Do 59, then do any of the odds 61 to 65, and then do either 67 or 69, okay? Don't get too bogged down with those, but we'll do that. Any questions? I think we're out of time now, aren't we? Okay, so we will start in 3.2 next time. All right, good deal. We'll see you both later today. All right.